Welcome back, and we are ready to move on to Notes 10-2B. And today is January, my smartboard's going a little wacky here, January 6th. So let's cruise on through these. Again, just like yesterday, do a little review for the final first. So going back a couple chapters, finding the solutions to a quadratic equation. And remember, this is when it's equal to 0. We're trying to figure out what values for x make it equal to 0. On this one, there's two ways you can do it, and I'll do it both ways for you. First of all is just to notice that you can solve this with straight up algebra 1. Because there is no x term, or what we like to call b term, you can just simply move that 4 over by adding it. You'll get x squared has to equal 4, and then when we take the square root of 4, we get, well, then x is 2. But keep in mind that -2, when I square it, also equals 4. So technically we say plus or minus 2, and that's one way to solve it. Or, I'm going to put a little divider here. You might notice that this is what we call a difference of squares, and you can factor it or unfoil it into x minus 2 times x plus 2. And you can decide, well, what makes each factor equal to 0? And the answer would be 2 or -2. So either way, we get the right answers. Next question, what is this binomial two-termer times another binomial? Well, we need to recognize that this is a case of the FOIL method for distribution. We do firsts. So the F stands for first. 2x times 2x gives me 4x to the second, because when we multiply, we add exponents. Then we do the outsides. So we kind of head to the outsides here, like kind of pretend you're heading on the outskirts. And I do 2x times 5 are the ones living on the outside. So the O stands for outsides. Yeah, it's hard to fit that in there. Let's write it over here. It stands for first. Outside. All right, so let's go do our outsides. We've got 2x times a positive 5 gives me a positive 10x. The I stands for the inside, so head on in, and you'll have a minus 5 times a 2x, which gives me a minus 10x. And then my L stands for the multiplying the last terms in each binomial, which in this one up here is -5. It's the last one in this binomial times 5, which is the last one in that one, which gives me a -25. And then we combine the O and the I whenever possible, which is most of the time. And in this case, they cancel out. So I end up with 4x squared minus 25 for my answer when I FOIL it. Because again, a positive 10x minus 10x gives me 0 of them. So a little review on FOILing. Next up, what are the coordinates of the vertex? The vertex is the turning point. So this is going up, 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 down, hits the vertex, and turns and comes back down. The coordinates means what are the directions to get there? Well, you'd go 0 along the x-axis, and you'd go 1 up the y-axis. So the vertex lives or has coordinates of 0, 1. And then remember from before Christmas, so done with the final review, that just like when we're multiplying, we can break it up, like we would say root 20 is root 4, root 5. We can also do that with division and say that the square root of A over B is the square root of A over the square root of B. And a lot of times that's really helpful when you're simplifying things. So let's turn the page, especially when there's a perfect square. Here they are coming back at you. Let's create them again for a little bit. 1 times 1, which is never helpful. 2 times 2, 3 times 3, 4 times 4, 5 times 5, blah, blah, blah. Those suckers that we really like to see because we know their roots. Especially when they're on the bottom, that's nice. So let's go take a look up here. Square root of 64 over 49, we're allowed to break it up. And both of those we know, or we should know. Square root of 64 is 8. 8 times 8 is 64. Square root of 49 is 7. So that fraction cleans up really nicely just because I could spot my perfect squares. Sometimes you won't see the perfect squares until you simplify any roots or fractions. So before we start any of these, I always would suggest that you go under that root and you simplify anything possible, because as long as it's, I call it in my class, both in or both out, as long as both are under the root, you can say 6 divided by 2 is 3, and you can clean that up as long as both are in. If one's out and one's in like this, then this is done. So as long as everything's under that root, it's perfectly legal for you to take that 8/50ths. Notice that they're both even and cancel out a 2. And when you do that, you end up getting a 4 on the top and a 25 on the bottom, which is really nice because you should be spotting those in your bestie pool of perfect squares over here. X cubed, when I take out an x, will leave me 2 x's up on the top. So when I simplify under that root, I end up getting a whole bunch of nice perfect squares because I can consider the top and the bottom separately. I know the square root of 4 is 2. I know the square root of x squared is x. And I know the square root of 25 is 5. So it all cleans up really slick once you spot those perfect squares. So on the bottom, I would like you to go try these. So maybe if the video could be paused momentarily, pop up a hand when you're done with all 3. When most hands are up, restart the video for me. All right, I'm back. Let's see how you did. And there's more than one way to do these, but I'm seeing perfect squares immediately. So my head is considering it like this, and I get 12/3. And maybe you did also, and if you did, that's great. However, keep in mind we always want to reduce any fractions and roots at the beginning and make sure it's done at the end. 12/3 is 4. Well, maybe little Billy Bob in the back of the room says, I didn't do it that way. You said if both are in, I can divide them. And maybe you did. And you said, well, if 144 divided by 9 is 16, although most people don't spot that readily. And square root of 16 is 4. You get the same answer. Both are 100% correct. I tend to gravitate towards this because I just see those perfect squares staring me in the face. The same thing with this one. Watch this, though. I mean, you can do these lots of different ways, but all of this is living under the root, so I'm going to go simplify it. I know 36 divided by 4 is a beautiful 9, and I love 9 because it's a perfect square. And when I divide an a out, I end up getting 2 left on the bottom. So I end up with a top-heavy 9 and a bottom-heavy a squared. However, they're both perfect squares, and I can consider that the square root of 9 over the square root of a squared. And I just get 3/a, which is really nice. The bottom one, and again, you might have done them differently, but the bottom one, there's really only one way to do. On the top, I have the square root of 25, and again, I'm going to picture this, nothing simplifies under those roots, so I'm going to consider it 2 separate ones. On the top, the square root of 25 is a lovely 5. The square root of y cubed, it'll pop 1y out, and it'll leave 1y in. We discussed that yesterday. On the bottom, the square root of z squared is z. The square root of 11 squared is 11. The square root of 7 squared is 7. The square root of Larood squared is Larood. You always get the same thing back when you square a square root. Now let's go to the next page. What made those so nice is that they had those perfect squares living on the bottom. But what about when it doesn't? And we did a little of this before Christmas as well. They're just going to get a little bit more complicated. So we do what's called rationalizing the denominator, which basically means get the root off the bottom. So when there's not a perfect square, I'm just going to call it a PS, on the bottom, what we do is we manipulate it to get that root off the bottom. Historically, they did that so they wouldn't have to divide by a big, long decimal. But when I'm looking at root 3/7, you might say, that's done. 3/7, it's as good as it gets. There's no perfect squares hiding out in there. It's good. However, historically, it wasn't considered good because they weren't allowed to leave a root on the bottom because longhand to divide by root 7 is really, really ugly. So what they would do is manipulate it. Watch how. They would multiply the top and the bottom by the root that they saw on the bottom. Here's why. This is really, anything over itself is really 1. Multiplying by 1 does not change the value of anything. If you're 15 and then I multiply your age by 1, you're still 15. So that blue root 7 over root 7 is really 1 in disguise. So it's not going to change the value of this, it's just going to change its appearance. So watch, on the top, when I multiply straight across, because both are in, I can multiply them, both in or both out, for multiplication and division. I get root 21. On the bottom, root 7 is root 7 squared, which is just 7. Now the question becomes, can you simplify that? Because 21 and 7 makes a 3 when you divide, but the answer is no, because one's in, one's out. The top of that really isn't a 21. You might be saying, well, I'm staring at a 21. Are you crazy? But it's the square root of 21, which is like 4 point something, something, something. There's really not a 21 on the top there. So when one's in, one's out, you do not start slashing at it. So then, this is kind of our motto of all of our square root stuff, that you always want to reduce or simplify any roots or fractions before you start and when you're done. What do I mean? Well, let's go take a look. Because 7 and 8 are both under the root, technically if I could simplify, I would. But 7/8 doesn't get any better. However, I'm looking on the bottom and I should spot that 8 as being unsimplified. And I would suggest that you take care of that right now. You don't have to, but it's a good rule to just anytime you spot those perfect squares hiding in there, deal with it. The square root of 8 has a 4 hiding in it. So we're going to think of it as root 4 times 2. And the square root of 4, we know, it's 2. So it's going to pop a 2 out, but it's going to leave the 2 in the end inside. Now, what we don't like on the bottom is this root. This is our problem. So to get rid of it, we multiply the top and the bottom by the root on the bottom. It's kind of like a little ditty there. The top and the bottom by the root on the bottom. On the top, because they are both under the root, I can multiply them and get the square root of 14n. On the bottom, I've got this 2 that's hanging out front, and then I've got root 2n times root 2n, which is the square root of 2n squared. They undo each other. That's the whole reason you're doing that process, is to get rid of that root. So really what I end up with on the top is the square root of 14n, and on the bottom, a 4n. Can you cancel the n's? No. Why not? One's in, one's out. Can you take a 2 out of the 14 and a 2 out of the 4? No. Why not? Because one's in, one's out. So what do? You circle it. So moving on to the next one. Can I simplify 2/3? No. So what do? I multiply the top and the bottom by the root on the bottom. Because they are both in, I get to multiply those. Root 3 is root 3 squared, which is just 3. Can you divide out of 3? No. Why not? Because one's in, one's out. So it's done. Now let's go to the next one here. I have eyeballs here because I want you to be spotting that we always try to simplify roots and fractions before you start. It makes life easier. So that 18, sorry, it's nice if you can spot that there's a 9 living in there. So what you're going to do is consider that root 9 times 2. And the square root of 9 is 3, so it's going to pop a 3 out of there. And I'll let you write that down. Make sure you understand what I did there. Technically, I could multiply the top and the bottom by the root on the bottom, but what that does is the numbers get big pretty quickly, and it makes it harder to simplify at the end. So I really think it would be in your best interest to simplify it before you start. So now what do? I multiply the top and the bottom by the root on the bottom. And I clean it up. When I multiply straight across, these are both under the root, so I get to multiply them, root 10m. On the bottom, I have this 3 hanging out front, so I'll put it down here. Root 2m times root 2m is root 2m squared. You might say, how about root 4m squared? Perfect, but the end result is that I end up getting rid of the root. So now when I clean up that bottom, I have root 10m, and on the bottom I have a 6m. Does anything cancel? No. Why not? One's in, one's out. Getting sick of me saying that? I'm getting sick of saying it. All right, last one up here. Can I simplify anything? No. But had this been a 9, because they're both under the root, I could call that root 3 actually. But unfortunately, nothing simplifies there. So what do? I have to get that root off the bottom. I multiply the top and the bottom by the root on the bottom. I head straight across. 7 times 3 is 21. S still hiding in there also. On the bottom, root 3 is root 3 squared, which is just 3. This double root thing going here always gets rid of it. Look here, root 3 is 3. Root 2m is just 2m. Root 3 is just 3. Can you cancel? No. 1 in, 1 out. And we are just about done here. So what I'd like you to do is try these 3 on your own. And again, keep in mind that you always simplify roots and fractions before you start and when you're done. So we've got 3 problems on here for you to try on your own. So if this video could be paused for probably about, I don't know, 5 minutes or so, and then restarted so they can get checked. All right, time to check. Let's see how we did. Can we simplify anything? The answer would be yes. I can knock an x out of the bottom. So really what I have is the square root of 15 over x squared. I could simplify under that root. Then I consider it root 15 over root x squared. This is actually a perfect square living under here. The square root of x squared is just x. So I'm done. There is no need to get any root off the bottom because it's self-destructed on its own once I simplified. So that's the quickest way. Always simplify any fraction that you can before you start. So using that method on the next one, can I simplify 5/3? Well, they're both under the root, so technically I could try, but there's nothing I can divide out of both. Like in this one, I could divide an x out of both. So what do? I multiply the top and the bottom by the root on the bottom. And what do I get? Root 15, and then over here, root 3 is just 3. And one's in, one's out, so I put it in a box and I move on to the next one. So this last one, there's several ways you could have done it, but here's what I would suggest. Again, because they are both under the root, you can take a 2 out of here and a 2 out of here. This is really, because they're both in. If one's in, one's out, you cannot do that. But this is really that once I take a 2 out. Now what's my problem? The root on the bottom. So what do? I multiply the top and the bottom by the root on the bottom. Let's go do that. On the top, I get root 3n, and on the bottom, root n is just n. Can you cancel the n's? Nope. Why not? Oh, because one's in and one's out. And we are done. Over and out. You'll be working on worksheet, and I kept that one to 17 minutes. I like to keep them at 15, but it's pretty good. We'll be working on 10.2B today. So that is what is due tomorrow. Have a good one, and if you need any help, you can run down the hall and ask me. Ciao for now.